Okay, we've been talking about Euler's totient function. Phi of n equals the number of integers less than or equal to n which are co-prime to n. So I'm just going to start mucking around with some evaluations of this. First thing is that if p is prime, this implies that phi of p equals p minus 1. Great. Dead easy. How about this? How about how about figuring out phi of p to the k? So if in other words we've got phi of n where n is a power of a prime. Well, what's that? Well, what we're going to do is we're going to start with p to the k, p to the power k, and we're just going to subtract off all the multiples of p. Remember, p is prime, so it's p to the k minus 1. I guess k has got to be greater than or equal to 1 here for that to work. So that's quite nice. So phi of p to the k equals p to the k times 1 minus 1 over p. Writing it in a rather peculiar way, but yeah, well actually, why not use that? So if n equals p1 to the alpha 1, p2 to the alpha 2, up to pr alpha r, then we can use the fact that phi of n, we can use the fact that phi of n is multiplicative. We can use that fact now to evaluate phi of n, rather than counting all the stupid things. Equals phi of p1 to the alpha 1 through pr alpha r equals, because all these guys, these are all distinct primes, so all these factors are relatively prime to one another, so it's phi of p1 to the alpha 1 times phi of p2 to the alpha 2 times all the way through to phi of p subscript r to the power alpha r equals p1 to the alpha 1, 1 minus 1 over p1 times, all I'm doing is using that formula up, this formula here, times p2 to the alpha 2, 1 minus 1 over p2 times all the way up to pr to the alpha r, 1 minus 1 over p subscript r equals p1 to the alpha 1 all the way through to pr to the alpha r, just collecting those terms together, times 1 minus 1 over p1, 1 minus 1 over p2, blah blah blah, 1 minus 1 over pr, and then I observe that that equals n, which is quite nice, equals n, 1 minus 1 over p1, 1 minus 1 over p2, blah blah blah, 1 minus 1 over pr. Which is a rather nice little sum. Let me write that out again. If n equals the product of pi to the alpha I, then phi of n equals n times the product of 1 minus 1 over pi, I equals 1 to r. I guess I could put the limits there, 1 to r as well. Okay, beautiful little theorem. I'm going to stop there.